Inscribed angles. So inscribed angle is an angle whose vertex is on the circle. So this is an example of an inscribed angle. Specifically, this is the vertex on the circle, and that will be the inscribed angle. The arc it faces, so the arc that it faces, is called the intercepted arc or the subtended arc. So this is facing that intercepted arc. The inscribed angle's measure is half of the central angle. This is the inscribed angle theorem. So, for example, here the inscribed angle, the one with the vertex on the circle, is 50. So this will be 100, and y will be 100. So I'm just doubling 50 to get 100 there. Here, I'm giving you the central angle, and x will be half of that, which is 30 degrees. The arc will also be 60 degrees because it's defined by the central angle. Here, what is y in terms of x? So y, that's the central angle, so it'll be the same as the arc. X, we'll have to double that to get y equals 2x. What's y in terms of x? Y is 2x. Y is going to be double the inscribed angle. There are three extensions of the inscribed angle theorem. One is that if we inscribe two angles on the same arc, then the angles must be congruent. So if you see this was x, then this will be 2x because it's double that one. Well, now if we want to look at this, coming from here, this is 2x, so we can cut it in half to get that. So then these two must have been the same. If you inscribe an angle in a semicircle is half a circle, then that angle is a right triangle. So here, if this is half a circle, if this is 180, then that's 180 degrees. And this angle looks at that 180 degrees, so it's going to be half of it, making it a 90-degree angle. And if you inscribe a quadrilateral in a circle, then the opposite angles are supplementary. So that's saying that if here's x and here's y, x faces part of the circle, so this will be 2x altogether. Y faces the other part of the circle, so that'll be 2y together. So 2x plus 2y will be 360. And then if we divide that by 2, we'll get x plus y is 180. So the opposite angles add up to 180. These two angles must add up to 180. So how do we apply this? Well, here, this faces this. So if we doubled that and then cut it in half, it would be the same as that. So we could say that 7z minus 4 equals 5z plus 20. We can solve that equation and get 2z equals 24, so z is 12. The measure of angle arc AB, we could plug back in 12 in here. 7 times 12 minus 4 is 84 minus 4. So that's 80, and the measurement of the arc would be double that, so 160 degrees would be our answer there. Find x and y. Okay, so this is an inscribed quadrilateral, which means that the opposite angles have to add up to 180. So I can do 180 is 88 plus y. And subtracting 88 from both sides gives me 92. Same thing with x. X plus 108 is going to add up to 180. So subtract 108 from both sides, and you get x is 72. This one's a little tricky because this is the center of the circle. That means this is the diameter. And this will be 180, including the 40. X faces all of that, so it'll be half of that. X is going to be 90 degrees because that's half of 180. All right, this is a tricky one. This 120 faces BD, so this is going to be 120 overall. Z is inscribed on that, so this will be half of that, so half of 120, this will be 60 degrees. if we look at the big quadrilateral, so far we've got z is 60. If we look at the big quadrilateral, z and x are inscribed on that same quadrilateral, so z plus x have to add up to 180. We said that z was 60, so x will have to be 120. Now, how do we find y? Well, this was 120. That means that this will be 240 because together they have to make 360 degrees. Also, if I look at the quadrilateral, if I look at this quadrilateral, the interior angles in a quadrilateral add up to 360 degrees. So the four of those will add up to 360. So 60 plus 24 plus 240 plus y is 360. So then when we solve that, we will get y equals, I believe, 36 degrees. All right, that's how we can apply inscribed angles.